Welcome back to Low Stress Math with Mrs. Bono. We are in Unit 5, Writing Linear Functions, Lesson 7. I can compare linear functions in different forms. And so far, we really have been comparing functions in different forms. We've been looking at tables, we've been looking at graphs, we've been looking at equations. This is really just a roundup of that. So let's take a look at some information. So functions can be represented by graphs, equations, tables of values. In the beginning, all the way back in chapter 4, when we first looked at functions, we did this. We compared them in all different forms. We even had a fourth one. Do you remember the fourth one? Do you? Come on, think about it. Oh, Bono, don't sing to us. All right, if you can't remember, you can always look back. Let's take a look back at linear functions in chapter 4 for a second. Okay, here we go. Way back in the beginning, we were looking at all kinds of different stuff here. I had a little chart for you, remember? We had ordered pairs, we had the domain and the range in a table, we had mapping diagrams where we were drawing arrows, we had graphs. So we had all these different ways. And now we've added equations into that. So even a mapping diagram can be shown this way. Now, you're gonna need a highlighter. You're gonna need 2 different color pens. I like red and blue, red and black, whatever, but 2 different colors so you can compare things. You're gonna do one function in one color and the other function in a different color. All right, so let's start with graphs, equations, tables of values, methods to find the rate of change. Rate of change. What does that mean? It means slope. Now, what letter do I use to represent rate of change? Well, I like to use the letter M because that's what's in the equation, y equals mx plus b, so m is the slope. So graphically, to find the slope, it's rise over run. So that would be an M. Or you could call it the change in y over the change in x. Remember that? Delta y over delta x. It's the same thing. In the equation, y equals mx plus b. M in the equation is your slope. And from a table of values, you remember you pick 2 points, an x1, a y1, an x2, a y2. That is another way to find the slope. All right, let's talk about some key words. There are a lot of different words for slope, and it's kind of important, so let's highlight this. There's rate of change, there's just rate, and this one per. And let's put a little star for per. Per means for one. And when you have a word problem, the word per tells you where to put your variable. So if it says $6 per pound, you know it's going to be 6x. Or 3 meters per 3 meters per second. You know the per is where you put that x. So per sort of tells you where to put the x. All right, keywords for the y-intercept. And I'm going to highlight a little extra here because of late we've been seeing different words for y-intercept. And one of them was vertical intercept. And I've run out of highlight. See, that's the problem when you highlight first. Sometimes you run out of highlight. So you have the vertical intercept. That's another way of saying the y-intercept. As a matter of fact, any word that means first. Any word that means first is a y-intercept or a vertical intercept. So, more highlighting. Starting point, fixed rate, that's going to be important. because it's not a regular rate, it's a fixed rate. And we will talk more about that. Initial, like an initial value, or a beginning, or a first, all those words mean the first, in the beginning. That's the initial value. That's the vertical intercept, or the y-intercept, or the b. So down here, let's do a practice problem. Let me make it a tiny bit bigger because it happens to be hard for me to read this one. The Bronx Zoo recently celebrated the birth of 2 new pandas. Huh, that's good. Which panda was heaviest when it was born? Ah, that's another word that means the first. Born means beginning. In the beginning, a panda was born. Okay, now I have 2 pandas here. Moshi, the panda cub, has been measured and weighed each week since she was born. Oh, Moshi's a she, that's good. And here's weeks, and here's her weight. This weight happens to be in pounds, but we'll get back to that. Moshi's brother, Kappa, he's a boy panda, his weight has been charted on this graph below. So, which panda was heavier when it was born? Means in the beginning, so this is y-intercept. They're asking what the y-intercept was. So, on a chart, the y-intercept is the y value when x equals 0. Here's x is 0, the y value is 1, so I'm going to make Moshi blue. Here we go, Moshi, you're going to be blue. And Moshi was 1 pound week 0. Week 0 was birth. So Moshi was 1 pound at birth. But the next one's a little bit harder. Kappa is a little bit harder. And I'm going to do Kappa with a red pen. And I'm looking at this, and it's really tiny to me, so I'll make it bigger. And you can see here, 0, and then 1, 2 boxes, 4, 1, 2 boxes, 8, 1, 2 boxes, 12. I have to think. Here's the thinking part. I'm actually going to even put a star. What does each box mean? What does each box mean? What is each box worth? I like worth better. So I'm actually going to change that. What is each box worth? So what is each box worth? That's a thinking thing. I got to think about that. Well, 2 boxes is 4. So let's see. I'm thinking real hard here. Got my thinking head on. To get from 0 to 4 is 2 boxes. To get from 0 to 2 is 1 box. So this 1 box is 2. 2 what? 2 pounds. So here's my Y line, and my Y-intercept is 2. So Kappa weighed 2 pounds at birth. Then it says, which panda was heavier? Well, if Kappa was 2 pounds and Moshi was 1 pound, obviously Kappa weighed more at birth. But I want to use their words. So it says, which panda was heavier when it was born? Kappa was heavier at birth. That's it. I don't have to explain anything. My explanation is up here. Here's my explanation, and here's my sentence answering the question. Okay. Determine the rate of change. Rate of change? What does that mean? Oh, wait, I know what rate of change is. That's a slope. Slope is the rate of change. So we're going to need to find the slope of each panda. So remember, we were doing Moshi in blue, and here's Moshi. Now, Moshi is a chart. So in order to do it from a table of values, I'm going to come back up here. To find the slope from a table of values, it's y2 minus y1 over x2 minus x1. Table of values. So let's come down here and look at Moshi and get that. M equals y2 minus y1 over x2 minus x1. And now I have to look here. You know what, I'll just take these bottom 2 points because it's easiest, and I have 2, 9 for my x1, y1, and 3, 13 for my x2, y2. Now I just have to fill those numbers into this formula, and that's easy enough. 13 minus 9, y2 minus y1, over 3 minus 2, x2 minus x1. 13 minus 9 is 4. 3 minus 2 is 1. So what does that mean? Well, the y value is weight, and that's in pounds. And the x value is the x value is weeks, and it's on the bottom, so that's weeks. So what does this mean? Moshi gained, because it's positive, 4 pounds per week. LB is abbreviation for pounds. It's short for Latin libra, so LB is pounds, so 4 pounds per week. Now, let's take a look at kappa. Here we go, kappa. Kappa is a graph. So I'm going to come up here, and what does a graph say? Graph says rise over run. So that's what we write for kappa. M equals rise over run. And it doesn't matter which 2 points you pick, just pick 2 points. So I'm just going to look at, make this as big as I can, rise and run. Here's rise. And what's my rise? It went up 1 box, but that's really 2 pounds. And run, which is 2 boxes, but really just 1 week. So rise is 2 over 1. Got to know what the boxes mean. 2 over 1. And that's 2 pounds in 1 week. So kappa gained 2, and remember, LB for pounds per WK for week. 2 pounds per week. All right. Which panda is growing at a faster rate? Well, let's look at them both now. Oh wait, Moshi's gaining 2 pounds per week. Kappa's gaining, no, Moshi's gaining 4 pounds per week. Kappa's gaining 2 pounds per week. 4 is bigger than 2, so Moshi wins. Moshi is growing at a faster rate. Go Moshi. There we go. Easy enough. Let's take a look at the next problem. So slow, Bum. Come on. There we go. Example 2. 2 trains begin their trip from the train station at the same time. That's some pretty interesting information. What is the initial distance for each train? Well, they both begin in the same place. So their initial distance is the same, and they're both 0. Train A starts at the train station. Well, so does train B, because it says the two trains begin their trip at the train station. So, how do I know? Both start at the train station. So their initial distance is the same. Oh my goodness, I forgot my E's on 2 words. That's not good. That's just definitely not good. B equals 0. They both start at 0. And I can even look over here and see D equals 35T, and it doesn't say plus or minus anything. That's another hint that they both start at 0, because they started from the same place, and train B is doing 35T. No plus or minus. What is the rate of change for each train? So let's look at train A. Train A starts from the station and travels at a constant rate of 60 miles in 2 hours. Okay. Well, rate of change, the slope here is m equals speed, miles over hours, or 60 over 2, which goes down to 30 miles 1 hour. So the rate of change for train A goes 30 miles per hour. You've seen miles per hour before. Slope is always miles per hour. All right, now let's take a look at train B. Here we go. D equals 35T. Oh, so the M is 35. Train B goes 35 miles per hour. Because the slope is m and there's no plus b. Y equals mx plus b. You could even write the rest of that there. Y equals mx plus b. Here, y is d, m is 35, x is t, b is 0, but we knew b was 0 from before. So which train is moving faster? Well, train B is going 35 miles an hour, and train A is only going 30 miles an hour. That's how I know silliness. Train B is going faster its speed 35 miles per hour is greater than 30 miles per hour. So it's going faster. All right, next one. Valerie and Oscar are contestants on The Biggest Loser. Their weight loss program is shown below. Oh, sorry, I read that wrong. Their weight loss progress is shown below. Valerie's weight loss is shown by the function where W is her weight and T is the time in weeks. You know, I'm actually just going to swap those because I like y equals mx plus b. My preference is this, y equals mx plus b. And this is the mx, because see there's a variable there. So I would rewrite that as w equals negative 2 5/10 t plus 235. It doesn't really matter, but Whatever is next to the variable is the M. So who weighed more in the beginning? Well, let's look at Valerie. Here's her B, 235 pounds. Valerie weighed 235 pounds. How do I know that? Because B is the beginning and B is 235 pounds. And let's look at Oscar. So Oscar's going to be blue. Week 0, this is his y-intercept. B equals 247. So Oscar weighed 247 pounds. Because week 0, 247 pounds. That's his y-intercept. This is her y-intercept. So who weighed more? Oscar weighed more. How do I know? Because I can read. I don't know. Here we go. Oscar weighed I keep putting a T in weighed. I don't know what's wrong with me. Oscar weighed more in the beginning. His y-intercept is larger. Right. Who's losing weight faster? Faster rate. Faster rate is slope. Now let's look at Valerie's slope. She is W equals negative 2.5 T plus 235. So Y equals MX plus T. M is negative 2.5. So that's negative 2.5 pounds lb per week. So she's doing a pretty good clip. That's, believe it or not, that's pretty good. Now let's look at Oscar. Oh dear, we're going to have to do the X1, Y1 thing. So let's take 2 points. 0, 247, and 2, 243. And this can be X1, Y1, X2, Y2. And M equals Y2 minus Y1 over X2 minus X1, 243, minus 247 over 2 minus 0. I put that in my calculator and I get M equals 2. Negative 2, sorry. Negative 2 pounds per week. Okay, so who lost more? Valerie. I didn't label my people. How bad of me. I'm going to label this as Oscar. And I'm going to write Valerie over here. It's very important to label your math. Because if you don't label your math, then the person grading it doesn't know that you know what you're doing. So squiggle, 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 Oscar's over there. And Valerie is losing more per week. Is losing more per week. She has a greater slope. She has a more negative slope.
8th graders, you may now move to your third period.
Because negative 2.5 is a more negative slope than negative 2. So she's losing more weight. Losing is a negative word. So she's losing more weight. All right, let's look at the next page. Bum, ba, bum, ba, da, bum, 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 bum. Closing. All right, in your words, explain what pieces of information are needed to compare two linear functions. How would you explain a method for comparing linear functions in different forms? Well, we keep looking for the same thing over and over and over again. We need the slope and the y-intercept to compare functions. So, let's write that down. You need the slope and y-intercept to compare functions. It is, in my opinion, easier to change all the functions into equations and then compare the equations. So for me, it's easier to write an equation for each function and then just compare the equations. It is easier to write an equation for each function and then compare the equations. All right, I think that you should pause the video right now and do this next problem. And when you come back, I'll go over it with you, but I would like you to try it on your own. Okay, I really hope you tried the problem. I do. All right. Joanne and Chris work for an electronics store. They both get a regular monthly salary, and they can make extra money, called a commission, by selling merchandise to customers. In other words, the more they sell, the more money they make. That's pretty good, like a car. Car salesmen get a salary, and then every time they sell a car, they get more money. So that's good. Most salesmen, even waiters and waitresses, work on that. They get a base salary, and then they get tips, which is like a commission. What is the rate of change and vertical intercept for the line that represents Joanne's total monthly earnings? All right, so here's the Y, which is total earnings in dollars. And then this is Joanne. So let's make Joanne the blue line. And here, where she hits the Y, that's her B. Joanne's B is $2,500. And then Chris, we're going to make Chris the red line, and his B is $1,500. So B equals $1,500 for Chris, and B equals $2,500 for Joanne. So that's the vertical intercept. Remember, vertical intercept is the same as the y-intercept. And the rate of change, that's the slope. So let's start with our girl Joanne. She's going to be blue. All right. Her, capitals bono, her vertical intercept is B equals $2,500. And her rate of change, rise over run, her slope, rise over run, equals, well, what is each box worth? We're back to thinking about that again, right? So to get from 1,500 to 2,000, That's 2 boxes. That's $500 is 2 boxes. So 1 box, 1 rise is $250. So if 2 boxes is 500, 1 box is 250. And in order to get that, she has to sell 2 boxes is 1, so 1,000, 2,000, 3,000, 4,000, $5,000 in merchandise. All right, so her rise over run is $250 over $5,000, because you have to read down here. It's sales in thousands. All right, so let's grab a calculator and figure that out. So 250 over 5,000 is 1 over 20. And what does that mean? It means she earns $1 for every $20 of merchandise that she sells. So she's earning, because it's Y, earning over sales, $1 per $20. So that's not horrible. So let's write that down. She earns $1 for every $20 in sales. But Chris has got a higher slope. You can see he's got a steeper slope. So what is the rate of change and the vertical intercept of the line that represents Chris's total monthly earnings? Well, his B, his vertical intercept, V-E, oh, come on, Bono, spell today. His vertical intercept is B equals 1,500. So his base salary is less money. He starts off with less money, but he's a better salesman. Because, well, maybe he's not a better salesman, but he is selling, he's earning more for his sales. So let's do his slope. His slope, rise over run, 1,500 to 2,000 is $500 over, well, here's 2,000, so this must be 2,500 in sales. Because remember, 1,000, 2,000, 3,000, right in the middle is where his dot is. This is 2,500 in sales. So let's reduce that down to lowest terms. We'll stick that in the happy calculator of math. Make a fraction, 500 over 2,500, and $1 for every $5 in sales. Wow, that's pretty good. He's earning $1 for every $5 in sales. So he earns $1 for every $5 in sales. Who sells more merchandise per month? Well, they didn't tell us that, did they? Are we going to assume that this dot is per month? Well, then Joanne sells more merchandise per month. But, I mean, I'm not really sure what they mean by that, because there's no months on here, is there? Who sells more merch? I can't answer that question because there is no time on here. But if I assume that that dot is there per month, then Joanne sells more merchandise per month because her dot is further to the right. So Joanne sells more merchandise. but she doesn't earn as much for selling. I don't like that question. How much commission does Joanne make per week? How much does Chris make per week? Well, if this is per month, right, then, but it does, then what do we say? If this is per month, then we'd have to divide it by 4 because there's 4 weeks in a month. Oh, okay. So how much commission did she make? She made $20 in commission because her dot is way over here. So, wait, no, she made $250. She rose $250 because she made a lot of sales. So $250 is her commission in 1 month. So then you would have to do 250 divided by 4 to get 1. This is going to be Joanne. I'll label things, Bono, Joanne. So let's see, 125, I can't do math in my head. Fraction it, 125 divided by, oh, sorry, clear. 120, no, 250, Bono. 250 divided by 4. She makes about $62.50 per month. Per week, sorry, $62.50 per week. And what does Chris make? Well, Chris got $500 in 1 month. So that's divided by 4. 500 divided by 4, he got $125 per week in commission. Interesting. Still don't like that question. Okay, I'll talk to you soon. Take care. Bye.